Welcome back, everybody. I've had a request to show number 20 from tonight's homework, page 295 in our textbook. I posted a link to the student solutions manual. It has both the solutions for odd and even problems. So the back of the book has all the answers, but that solutions manual actually has the solutions showing one step at a time. Sometimes it's hard to decipher what they're doing without a video. So if you get stuck, you can refer to the solutions manual, again, posted on the assignments page at the top, or you can email me and I'll try to get a video quickly posted online. So the problem with this one is finding the derivative. It's been a long time since we've done the quotient rule, but finding the derivative of the position function will give you the velocity. This is a quotient. You could wrap this up in parentheses, raise it to the negative first power and cross that fraction bar, use the product rule, or it'll be easier for us to set it equal to 0 if we just use the quotient rule. And that is low times the derivative of the high minus high times the derivative of the low over the square of the low we go. Let's clean this thing up a bit. This will be minus 2t squared. We can combine that with that t squared, and the top becomes negative t squared plus 4 all over this quantity. That's what the velocity machine is. Later on, we're going to have to find out where the particle is stopped, so we're going to set that equal to 0. Luckily for us, the denominator will never be 0. Okay, those would be points of non-differentiability. We would put them on the slope of the tangent line testing number line, but there are none. Cross multiply and get, or t squared equals regular 4, and take the square root. You get plus or minus 2, but all physicists know that you don't start an experiment with negative time, and they even say in this particular problem, they want to restrict the domain to just positive numbers. That way we can throw out that negative t equals negative 2. Put it on a velocity testing number line, and here we go at 2. We test a number that's not critical, like 0. If we test 0 into this original equation, you would get a positive on top divided by a positive on the bottom, which is a positive. So it would alternate on either side. Remember from previous chapters, we would put this negative 2 on there and it would alternate on that side as well, but we're not looking at it down here in the negatives. In fact, we're going to make a vertical bar and start with t equals 0 as our starting point. We'll riddle this area with positives, likewise with negatives, and now let's find the acceleration. The acceleration is one derivative away from the velocity or two derivatives away from the position function. So take the simplified version of the velocity machine and take its derivative. Good God. It is low times the derivative of the high minus high times the derivative of the low. That requires the chain rule. It's the derivative of the outer function. Leave the inside stuff alone. And it decreases by 1 times the derivative of the inside stuff. Over the square of the low we go, to the 4th. Set the acceleration equal to 0 to find when the acceleration is 0. Cross multiply, again. No points of non-differentiability here either, so that was lucky for us. Oh God, here we go. Set the top equal to 0. Now I noticed something in the top. We've got this package in common We've got a negative 2t in common. So let's factor those items out. Factoring out a negative 2t, that's gone. I can change this to a positive and factor out the negative 2t here at the end, and that's gone. Factor out another binomial that they have in common. One of those is gone, and one of those is gone. Do you remember doing factoring similar to this first semester? Let's write down everything that's left. What's left in this first is just one of those packages. What's left in this second, remember we already factored out that negative, so we don't have to distribute anything except for this 2. Distributing that 2, boom, boom, there it is, minus 2t squared plus 8. So far, so good. Combine some like terms. Plus 12. Guys, I hope I did that right. If you were sitting there, you could help me for sure. Set this part of the package equal to 0, get t equals 0, that's the border line. Set this part of it equal to 0, you would get 2 imaginary numbers, and we're going to toss those suckers out. Set this part of it equal to 0 and solve. Take the square root of both sides, you get plus and minus. We're going to throw out the negative 1, and 12 we'll rewrite as 4 times 3. The square root of 4 comes out as a 2, so another t value is 2 root 3. So far, so good. Let's put that on an acceleration testing number line. It used to be called the concavity test, and now we're putting our critical values right up on there. 2 root 3, let me figure out what that is as a decimal real quick. That's the square root of 12. What? Nice. 2 root 3. And the decimal equivalent, 3.46. I need to know that because right beneath 2, I need to know where exactly is 3.46. Well, it's over here somewhere. So this is where positive 2 root 3 is. Now, we test a value into the concavity testing machine. So in this nasty machine, we're going to have to find the nature of the acceleration at various spots. Okay, that looks ugly. So we're going to find the nature of the acceleration by testing a point. Can't use 0 because that was critical. Test a point like 1. If we put a 1 in there, this is going to turn into negative 2 times 5 squared. So negative 50. If we put a 1 in here, I can hardly see this stuff. If we put a 1 in here, remember we're going to subtract. We'll get 3 times 2 is 6, times 5 is 30, times 2t, so times 2 is 60. And hopefully I haven't forgotten anything. Negative. So I get the acceleration is negative in this zone. To find the intervals in which it's speeding up or slowing down, put a vertical line through these critical values, a critical value from the second derivative test as well. And then you can see where the velocity and the acceleration have opposite signs, it's slowing down from 0 to 2. When they have the same side, it's speeding up from 2 to 2 root 3. When they have opposite signs, it's slowing down from 2 root 3 to positive infinity. I know I didn't answer all those questions for 20. Check out the solutions on page 216. You don't have to flip through that solutions manual. Just in that Adobe type in the upper left-hand corner, page 216, you'll go straight to the page that has number 20 solution. Thanks so much. I hope this is helpful. Tell your friends. Don't forget to log in and have attendance taken care of. Tomorrow there's going to be, I'm going to give you a survey tomorrow so that you'll have to log in to get attendance, and you'll have to log in for my survey as well. Talk to you soon.